Hello, everyone, and welcome to my final project presentation for this semester-long project. I analyzed a UFC dataset, UFC fighter dataset, using different data science techniques, including data cleaning, exploratory data analysis, um, visualizations, and statistical analysis. Throughout this project, I focused on understanding relationships between fighter characteristics and also as well as like identifying meaningful patterns within the data. My project mainly focused on the relationship between like fighter height and reach and fighter reach, like with their arms, and whether taller fighters tend to have longer reach. In this presentation, I will walk through the process I followed, the methods I used, and then the results I found, as well as the like conclusions I was able to make with from the data that I pulled from the data set. Um, so yeah, we'll go into the introduction and basically the research question. So, um, for this project, I chose a UFC dataset because I love UFC. It's interesting. I always watch and like sports analytics in general. Within mixed martial arts is very interesting to me. The UFC contains a large amount of statistical and physical data on fighters, which makes it a pretty good data set for analysis. As I started exploring the data during the earlier phases of the project, I noticed that the taller fighters often appear to have longer reach. You could kind of see that in in the left side. I have a picture of the fighter's height as well as his reach. And as I started exploring the data, I I kind of realized like what my main research question was, which was, is there a significant relationship between fighter height and reach? My hypothesis was that taller fighters generally tend to have greater reach. This relationship is important because reach is often considered a major advantage in combat sports like fighting, boxing, jiu-jitsu, especially in striking situations like the UFC, situations where fighters try to maintain distance from opponents. Another reason this topic interests me is because sports organizations today increasingly use data analytics to evaluate athletes, as well as like identifying their strengths and weaknesses and improving performance. UFC statistics provide a good example of how data science can be applied to sports. Um, so yeah, that was basically my introduction, my research question, my hypothesis. Um, Moving to the dataset source. Um, the dataset I used for this project was the Ultimate UFC dataset from Kaggle. Kaggle is a popular platform that provides publicly available datasets for data science and machine learning projects. The dataset included over 6,000 rows of UFC fighter information, along with more than 100 variables. Some of the key variables included fighter height, fighter reach, age, weight class, striking statistics, win streaks, losses, and betting odds. For my analysis, I mainly focused on physical characteristics, such as height and reach, because these are the variables like directly related to my research question. I chose this dataset because it was large enough to allow meaningful analysis while also being manageable to work with in Google Colab using Python. It also contained a mix of numeric categorical variables, which made it useful for different kinds of analysis and visualization. Moving on to the next slide, data cleaning. So before analyzing the data set, I needed to clean the data. Data cleaning is one of the most like important parts of the data science process because inaccurate or inconsistent data can lead to misleading results. The first thing I did was remove duplicate rows to avoid repeated observations affecting the analysis. Then I standardized the column names by converting them to lowercase and removing spaces. This made the dataset easier to work with in Python. Next, I handled missing values in important variables such as height and reach because that's what we're looking at. And you can see on the left kind of like the data cleaning process. Rows that were like missing critical information were removed from the analysis because they could interfere with statistical calculations. Also, I also cleaned text formatting issues and converted certain columns into like numeric format where necessary. These cleaning steps improved reliability of the data and ensured that the analysis would be based on more accurate information. For this project, I used Python and Google Colab, along with libraries such as Pandas, Matplotlib, Seaborn, and yeah. So moving on to slide 5, exploratory data analysis. After cleaning the data set, I moved on to exploratory data analysis, which is also known as EDA. The purpose of EDA is to better understand the structure of the data and identify patterns, trends, and relationships. I started by calculating descriptive statistics such as the mean, median, standard deviation, minimum values, and maximum values. These statistics helped summarize the data set and gave a better understanding of how fighters differ from one another. One of the first things I noticed was that there was significant variation in fighter height and reach. Some of the fighters were much taller and had greater reach than others. I also observed that weight class had a strong effect on physical measurements. Additionally, most fighters appeared to fall within a similar age range, while only a few fighters were much older than or younger than average. So yeah, the goals were just to understand the structure of the data, identify patterns and trends, and prepare for statistical analysis. So my first visualization we could see here is the histogram. Is the histogram. Um, it shows like a distribution of the fighter heights. Histogram is useful because it allows us to see like how numerical values are distributed across the data set. From this chart, we could see that most fighters fall within a central height range. Only a small number of fighters are significantly shorter or taller than the majority, and this suggests that fighter heights are concentrated around average values rather than being evenly spread across all possible heights. The histogram helps us identify whether the data is skewed or if there are any unusual values, basically of the outliers. Next visualization, we have the bar chart. It shows the number of fighters or fights in each weight class. Well, in this case, it will be height in the one example that I have on the screen. So one thing I observed is that some weight classes, certain contain more fighters than others. This may kind of like reflect the differences in popularity because there's a lot of fighters in different weight classes. Another observation is that weight class strongly influences physical characteristics. Fighters in heavier divisions generally tend to be taller and have greater reach than fighters in lighter divisions. And that was something I noticed through the bar chart. The next visualization is the scatter plot. One of the most important visualizations in the project for sure, because it directly shows the height and reach comparison, and it kind of we'll see that like each point on this graph represents a fighter, and the upward trend visibly in the scatter plot suggests a positive relationship between height and reach. In other words, taller fighters generally tend to have longer reach. The scatter plot also helped us prepare for the statistical analysis because it visually suggested that the relationship between the variables might be strong enough for correlation and regression analysis. And if we go to statistical analysis, we could see that I use the Pearson correlation analysis, which measures the strength and direction of the relationship between two variables. We could see that and my correlation coefficient is 0.9, which basically means that like very close to 1, which means that there's a super positive relationship between the two variables. And then if you look at the p-value, is extremely small, which means that the relationship is statistically insignificant and very unlikely to have occurred by random chance. Next, I used a simple linear regression. In this model, height was used as the predictor variable, while reach was used as the response variable. And yeah, I also calculated the R-square value, which measures how much of the variation is reached can be explained by height. Of the variation in reach can be explained by height. The R-squared value was Relatively high, showing the height explains a large portion of the variation in reach. Finally is my conclusion and limitations. So I came to the conclusion that height and reach are strongly related within the UFC fighters and the data that I was provided with, or that I chose, the data set that I chose. So, and throughout this project, I applied several data science techniques, including data cleaning, exploratory analysis, visualizations, correlation analysis, and linear regression. And this descriptive statistics and visualizations helped identify important patterns, while the statistical methods provided evidence that the relationship between height and reach was statistically significant. Um, there were some limitations, such as limited variables in the dataset. Other factors influence like fighter success also, and regression model does not really explain everything. But for future improvement, I think we could um, definitely use more advanced machine learning models. That would probably do a lot of numbers, be able to really like give us like better understanding of like height and reach and weight, even if we add that in as well, weight class. Um, but yeah, I think it was a successful project nonetheless, and thank you for listening to my presentation.